Don't know much about algebra. Don't know what a sliding rule is for. But I do know what it was to. And this one could be with you. What a wonderful world this would be.
Welcome back, everybody, to Mr. K's 30 Minutes with Math. I hope you're all doing well on this beautiful Wednesday afternoon. We've got lots to dig into today, so let's get rolling. We're going to start, as always, with our math riddle from yesterday. I hope you guys had some fun trying to figure it out. So let me turn off the video. I'll focus on the riddle. 1 second here. All right, let us begin. So, as you may recall, we had this series of numbers and a few mathematical signs. So we had 2, 3, 4, 5, and the plus sign and the equal sign. And the question was, how could we use all of these numbers and symbols to create an equation that's true? So I'm curious, did anybody have any success figuring this one out? 2, 3, 4, 5, plus and equal sign. If you were able to figure it out, congratulations. That is fantastic. As you can remember, perhaps, I shared a hint with everyone to remember our squares. And by squares, remember 2 squared equals 2 times 2, which is 4. 3 squared equals 3 times 3, which equals 9. 4 squared equals 4 times 4, which equals 16, and so on. So you've got the idea. So let's see what the answer was. Drum roll, please. There it is. 4 plus 5 equals 3 squared. So let's check everything. 4, there's our 4, plus, there's our plus, 5, there's our 5, equals, good, 3, and then squared. So we have everything we need. Let's review how this would go. 4 plus 5, easy peasy, that's 9, equals 3 squared. 3 squared, we know, is 3 times 3, which is also 9. So there you have it. That was the answer to the math riddle of the day. All right, let's move on to our fractions work for today. This was our homework from last night. And remember, all we were doing is estimating to the nearest half, So didn't need to solve these exactly, just wanted to do estimates to the nearest half. All right, so let's take a look. 55 57ths. Well, that is really close to 57 57ths, which would be 1 whole, okay? Plus 7 halves. Well, let's do some number bonds here. 2 halves, and 2 more halves, and 2 more halves. That's 1, 2, 3 wholes. And then we'd have 1 half left. So that would be 1, 2, 3, and a half. All right. Then we have, that's done. Then we have minus 77 78ths, which is really close to 78 78ths, or 1 whole, plus 81 40ths. Well, let's do some number bonds. 40 40ths, that's 1 whole, and another 40 40ths, that's another whole, and then we'd have 1 40th left. So we'd have 1, 2, whoops, the ruler came out. We'll get back to that in a second. So that'd be 2 wholes and 1 40th. 1 40th is really small, close to 0. So we will go with 2 plus 16 14ths. Well, that would be 14 14ths and 2 14ths. 14/14 is 1, and 2/14 is pretty close to 0. So let's round this, estimate this at 1, and then, whoops, minus, let's get rid of that dot, 22/25, which is pretty close to 25/25. So that would be minus 1. So there we have it. 1 plus 3.5 is 4.5. Minus 1 is 3.5. Plus 2 is 5.5. Plus 1, 6.5. Minus 1, 5.5. So there you have it. That is your answer for last night's ruler. I know you're excited about the ruler. We will, last night's homework, and everybody's excited about the ruler. We'll get there in 1 second. Before we do, I wanted to try some more complicated problems that make you think a little bit more. I want you to go ahead and read this one, give it a try. Use the read, draw, and solve method. So read it closely, draw a picture to help you make sense of what it's saying, and then try to solve it. I'll give you a couple of minutes on that one with a little bit of music. Here you go. Okay, welcome back, everybody. Sorry for my very sad looking shark that I was trying to draw. Let's take a look at this one and see if we can figure it out together. Donna has written in 4.5. Let's see how we do. So we're feeding sharks. That's what we're doing here, feeding sharks. Let's just make sure we keep that in mind. And we feed them 3 times a day. We're feeding sharks 3 times a day. In the morning feeding, they get 2/15 of a ton, 2/15 of a ton of fish. So morning, 2/15 of a ton. During the afternoon feeding, the weight of fish fed will be 1/5 of a ton more than the fish fed in the morning. 1/5 of a ton more than the fish in the morning. So we had 2/5 of a ton in the morning, 2/15. We had 1/15 more in the afternoon. So in the afternoon, we have 3/15, okay? And the total weight of the fish in the day is 1/2 a ton. So the total, so morning plus afternoon plus night equals 1/2 a ton, 1/2 a ton. All right, so let's look at it then like this. That would tell us that morning whoops, 2/15 plus afternoon, 3/15 plus night, we'll just say night, we don't know what night is, equals half of a ton. All right, so we've got 15ths and halves. Let's decompose both of those, 15ths and halves, into 30ths. So 2/15, 15 times 2 and 2 times 2 would give us 4/30. So that one is 4/30. Then 3/15, equals 30ths. We'd multiply the numerator and the denominator by 2. So this one is 6/30. So 4 and 6, that would give us 10/30 plus the night equals a half. How many 30ths is a half? Well, we know that's 15/30. So if the morning and the afternoon are 10 and the total are 15, then the night must be 5/30 of a ton. 5/30. That was a complicated one. You had to think quite a bit. All right, let's try one more and then we will jump to our joke of the day. Here it is. A baby otter, which is very cute, was born 3/4 of a month early. At birth, its weight was 7/8 kilograms, which is 9/10 kilograms less than the average weight of a newborn otter in the aquarium. So what is the average weight? What is the average weight? We know at birth its weight was 7/8 kilograms, and that's 9/10 less than the average weight. Go ahead and try that one. And Baby Yoda, not Baby Otter. Yes, let's look if we can find a Baby Yoda. Okay, welcome back. I hope you enjoyed my Baby Yoda. Let's take a look at this one. A baby otter was born 3/4 of a month early. 3/4 of a month early. This is a distraction. It has nothing to do with the math that we need to do. It's put in there to make sure you're paying attention. Really, all we care about is the weight. So when it was born, its weight was 7/8 kilograms. So 7/8, by the way, we write kilograms, kg. That's how much it was when born. Okay, and then we find out that this is 9/8 less than the average weight. 9/8 less than the average weight. So if we take the average otter, and we compare it to this guy, we know this guy is 9/10 kilograms less than the average. So the average is bigger. Okay, so what do? Well, if we want to find out the average, we know that's bigger because we know the 7/8 kilogram is 9/10 less than the average. Well, then let's add 9/10 to the one that was born, 7/8, and that will give us the average weight. So let me get rid of all that. If we have 7/8, that's what it was when it was born, and we add the amount that it was less than the average, we'll get the average. All right, so we'll get to the joke. 1 second. So we need to decompose the eighths and the tenths. 7/8. Let's go to 80ths. All right, we're going to multiply the numerator and the denominator by 10, which would give us 70/80ths. Plus, we'll do our 9/10ths over here, decompose that into 80ths, and that would give us 72/80ths. So 70/80ths plus 72/80ths would give us 142/80ths. All right, now let's turn that into a mixed number. Let me get rid of all this so we have some space. 1 second, getting rid of it all. Okay, 142/80ths would give us 80/80ths. That's one part of our number bond. And then we would have 62/80ths left. So 1 and 62/80ths. And you could simplify that 62/80ths by composing it down. Let's see if we divided the numerator and denominator by 2, we would get 31/40ths. So 1 and 31/40ths. And I think we had somebody write that in. Yes, let me check. Yes, Ezra did. Well done. Fantastic. Anybody else who got it? Very, very impressed. All right, time for our math joke of the day. Why? Uh-oh, I don't know why it says why was, but let me fix that for you. Let's do this and this. Why did the origin need so many Band-Aids? Why did the origin need so many Band-Aids? Go ahead and take a second to think about that one. I'll give you some Jeopardy music. Okay, welcome back, everybody. All right, why did the origin need so many Band-Aids? And here is our answer. Sorry about that. Here it is. Because he always had 2 axes running through him. So 2 axes, that is a play on words, because remember, these are our axes. The plural of axis is axes, but that is also axes, you know, this thing that you can use to chop wood and stuff. So there you have it. He always had 2 axes running through him because, again, as you may recall from our earlier lessons, here's the origin right there where the 2 axes cross. So he always has 2 axes running through him. All right, are you ready for the ruler? I know everybody's excited for the ruler. Here it comes, our ruler, yay! All right, let's try another one of our slope problems. As we talked about, I believe it was yesterday, we started to talk about slope, which was kind of cool. So here's my line. And now you can say bye to the ruler. Bye, ruler. It's a line, so it goes on forever. And let me give you 2 points I want you to look at. So here in green is point A. And here, let's do red, is point B. So my first question is, what is the right coordinates for A? And what is the right set of coordinates for B? Go ahead and write that in. A and B. What would A be? And what would B be? All right, I'll give you a second to think about that one and write it in. Okay, welcome back. I'm gonna bring the ruler back just so it's here so you guys can see it. I know you love the ruler so much. All right, A is, let's see, how far is it on the x-axis? 1, 2, 3. And how far is it on the y-axis? 1, 2. Well done. And B, how far is it on the x-axis? 1, 2, 3, 4, 5, 6. And on the y-axis, 1, 2, 3, 4. Excellent job. So those are our coordinates, 3, 2, and 6, 4. Now the question is, what is the slope? The slope of the line. And if you remember, the slope is how much it rises, the rise, over how much it runs, the run. And remember, this would be a steep slope. And now I'm getting to a shallower slope. So this would be a steep hill to ski down or ride your bike down or run down. That would be very crazy. This would be a more reasonable slope, and this would be a nice, easy slope. All right, so rise over run. So let's see, and I'm gonna do this using blue. So if we start at A, how much do we rise to get to B? 1, 2. So that's our rise. And our run, how much does it take to get to B? 1, 2, 3. So the slope of that line is 2/3. 2/3. All right, I would like you to tell me, bring our ruler back, what is the slope of this green line? Go ahead and take a second and work on that one. What is the slope of the green line? And I would encourage you to use this as one of your points and this as one of your points. What is the slope? Rise over run. Go ahead and take a second to work on that. Rise over run for the green one. I'm going to erase this so we have a little bit more room. And remember, the slope is the rise over the run. And you can go from this point. Whoa, what happened? Let me bring it back. Sorry about that. Rise over run. All right, folks are writing in. We have a few with 4 over 1, or a slope of 4. It's the same thing. Let's check. And I'm going to use green to show this. How much are we rising? 1, 2, 3, 4. Very good. And how much are we running across? 1. So there you have it. That is absolutely correct. Well done. Well done. All right. Now let's try one more. Let me do some erasing so we have a little bit more space. All right. All right. All right. All right. Let's get rid of this. Okay. Let's bring our ruler back. And I think I'm gonna go with something like, oh, let me see if I can line it up. There we go. Let's use red for this one. And let me get the marker out. Okay. What is the slope of that line? And I'm not gonna label any points for you this time. Find 2 points, any 2 points, and determine where it is rising and where it is running. I would encourage you to find somewhere the line crosses right through an intersection, right through. If you have the line crossing in the middle of an intersection, it's harder to do because then you'd have to approximate where is it crossing. Is that -5, -5.5, or a little bit less? So find where it crosses over an actual intersection. Okay, we have some folks writing in 5/1 or 5. Let's take a look. I'm going to use this point right here because it's crossing right at the intersection, and this point right here because it's crossing right over the intersection. Now you can use any points you want. I'm just using those two because it's simplest to do. All right, rise. How much are we rising? 1. And how much are we running? 1, 2, 3, 4. There you have it, 1/4. So that is a shallow slope, because you can see it's not very steep. All right, well done, folks. We're going to come back to this tomorrow. We'll bring the ruler back and get a little bit deeper into our coordinate plane and getting onto algebra. All right, I am going to give you one more before we get to our homework. One more word problem with our fractions from our aquarium. An octopus weighed 5/6 kilograms. After 2 weeks, its weight was increased by 3/10 kilograms, but afterwards it lost 1/5 kilograms because it was sick. Ah, that's kind of sad. What is its current weight? What is its current weight? So it weighed 5/6, and then it increased, it went up by 3/10, but then it lost 1/5 kilogram. So how much does it weigh right now? Go ahead and work on that one. I'll be back in 1 minute. Listen to the music and work on the problem. Okay, welcome back, everybody. Let's see how we are doing. We are going to convert our 6ths, 10ths, and 5ths. We're going to decompose all of those into 60ths. So to do that with our 6ths, we can decompose by multiplying our numerator and denominator by 10. So that would be 50 60ths. Then our 10ths, we can decompose into 60ths by multiplying by 6. Our 5ths, we can decompose into 60ths by multiplying by 12. Okay, so now let's rewrite our problem. 5/6, well, we know now that's the same as 50 60ths, plus 3/10, which we know is the same as 18 60ths, minus 1/5, which we know is the same as 12/60. Okay, 50 plus 18 is 68, and then 68 minus 12 is 56/60. And we can simplify that a little bit more. Let's compose those 60ths. Let's start by dividing by 2, and that would give us 28/60. We could keep going. I'm sorry, 28/30. Let's divide by 2 again. We can keep composing this into larger fractional units into 14/15. So almost 1 kilogram, almost 1 kilogram. All right, here is your homework for tonight. The Penguin Nursery is open 2 times a day, 2/3 of an hour at noon and 5/12 of an hour in the afternoon. How much time is the Penguin Nursery open every day? Go ahead and take a quick screenshot or write that one down or take a picture, and we'll get to tonight's riddle. Here it is. What number will replace the question mark? What number will replace the question mark? And so what you have to do is you have to look at this figure. It looks kind of like a pizza pie, a strange one, and figure out there is a certain pattern going on. And if you can figure out the pattern, you can check it by looking at all the numbers. You'll be able to figure out what the question mark should be. All right, everybody, have a wonderful afternoon. It's been great to see you all, work with you all, and I'll be back tomorrow at 2. Bye, everybody.